this channel. I've taken an absence for quite a while. I had to do that because I had to find myself, and I'm thankful to say that I am a full-time software developer now. Actually a mobile developer. I wanted to show you some of the stuff I'm doing there, and I'm also going to show you some of the goals and things I'm trying to set for myself right now. Now, although you can see that I've got the emulator up on the screen here for the Atari, and I want to show you this program in a minute. I'm not completely back into it because I do have a social life now and I kind of get out. But right now, the reason why you're going to see this video is because of this. If you can see that or not. That's what's left of my car after yesterday. It was a pretty nasty accident, so I can't really go driving it around anywhere. It is drivable, but I'm just not going to take a chance on damaging it any further. So right now, I'm at home, my apartment here in Phoenix, Arizona, so I'm going to show you some Atari stuff and whatnot. So before I do that, I wanted to show you also, this is the application. For those who are curious, this is what I do now. I'm a mobile application designer. This is one of the applications I'm working on at work. Basically, this one you're seeing right here is used in the medical field, and I don't know if you can see it or not, if I can change the screens there. And I'm redesigning it so it works on more mobile devices right now. It's only currently working on the iPhone, but I'll show you the one that I actually designed, and they actually uploaded it, so I can show it to you, although it's still not working right. So this is actually the screens I redesigned. Notice it has a little bit more color to it than the other ones, and it also rotates as you move the phone, where the other one doesn't do that. It's supposed to be if you hit on these screens here, changes the background. You see, you hit the screens right here. These are called the list views. I don't know if I can do it backward or not. Now this one's kind of frozen. I kept telling them they need probably put a reset on this because the screens are freezing up. See if I can get it to work. There's the login screen right there. I designed that one too. But anyways, kind of see that's what I'm doing. It's hooked up to a database and everything. But anyway, to not get too far off the subject, somebody told me once last year, it was early this year, since I was struggling so much to get back into this industry, they said, what you might want to do is, tone it down on the Atari videos and concentrate more on your field, which would obviously at that time been .NET, or Visual Studio C#. And I took their advice to heart and decided to stop the Atari videos and Commodore videos and just basically walked away from it and started, studying the other stuff. And well, it paid off. I'm a full-time developer now for this company. I won't say what company for non-disclosure here, but it's a great company. It's in the medical field, and I'm getting a pretty good salary, so I'm pretty happy. And we're getting pretty close to finishing the first mobile application here. So enough said of that, and let me show you some of the Atari stuff I've been working on here. This is just a simple program I was playing with earlier. I wanted to show it to some people. It's just a random drawing thing. It kind of draws in variations. You can kind of draw weird pictures and stuff like that. It's the kind of stuff I used to like to do back in the days when I was really into the Atari back in the 80s and everything. And you can kind of see and I think it's supposed to be moving over. Yeah, it's moving over slightly because it's moving in increments of, I think, 2. But it's also moving up the screen here in Y. So this is actually the vertical and this is the horizontal. So it takes a little bit of time because it's also plotting down the numbers here. These are the coloring, the numbers changing as the colors are moving on the screen, which is what gets the fancy colors there. So let me show you that once again here in the program. So basically what it's doing here, you see where it says for x equals 1 to 38. It's going across the screen here and it's drawn from 1 to 38, which is why you see it drawn all the way over like that. And it's moving up in Y. So Y is changing and X is changing on random variables here as it's moving up the screen. So you see here it says X plus 2, so it draws over from position X, which starts at 1 here. And remember, since it's drawn over 38, it's actually changing and adding 2 to it times a random number. So it's picking a number between 0 to 10. And that's how it's kind of drawing the screens like that in different variations. And it's doing the same thing with Y, except I shortened it to 5, so it kind of would stay on the screen and stuff like that. And this right here is just changing the color on every 2 increments. So if you see something like int a divided by 2 equals a divided by 2, It's calculating A, because here it's moving A equals A plus 1, not to go over 4, and flipping it back each time so that A always stays in those 2 increments. And that's why you see the numbers incrementing down the screen there from 1 to 4. Well, actually, that's because of that, but this is what's changing the colors, actually. Because right here it says color C, so it's plotting in the colors. I did something else to this earlier. Let's see, I think if you played with these numbers, I think this is what I did earlier. Let's see, 10. I don't know if I can change this to 10. Maybe make this like 12 or something. I don't know. Let's see if that changes anything. I had to doing some really weird stuff earlier. Yeah, that's errors. Okay, so I went too far there. So I miscalculated. So that's why I didn't try to set the numbers too high. You'd want to set them lower, actually, to avoid any errors like that, because it's drawing outside the screen range. That might still draw outside too, and it does. That's why I kept them in a certain range. So this 10 is too high, so I might want to lower this to like maybe 3 or something. I think that might do it right there. There, and you see how it kind of changes them each time. It's just changing the width between the drawing and stuff like that. But that's just one of the simple programs I was working on. So I'll just reset that one. I don't intend to save it. It's a very short program. I could just type it in again if I need to. But for those who know me, I also was doing videos on the Commodore 64. This is the map of the Commodore 64 book. And this is the Atari map and the Atari book. So those are the 2 popular ones that were popular back in the days. So I was going to show you some Atari stuff. I'm sorry, some Commodore stuff here. But I can't find my WinVice anywhere. I had formatted this computer a while ago. For those who want to see, I'll show you the computer here real quickly. I don't know if you've ever seen it. This is my computer, basically my computer setup here. And there's an Alienware computer there. And so when it changes the colors on both sides here, you can kind of see it. You can change the colors. I don't have the tools to do it right now. I don't have them hooked up where you could actually change the colors and show it to you. This isn't a video to show you the computer. I just wanted, if you wanted to see it, curiously. And yeah, anyway. So let's get back to the real good nitty-gritty stuff, right? Still have the same camera. Sometimes it adjusts, sometimes it doesn't. Okay, there it goes. Alright, so back to the computer here. I'm trying to think of some of the things I haven't showed you yet. Probably more of the focus here would be on the assembly language. A lot of people were really curious and interested about that when I really got into that one time. So we'll erase this one for now, kind of see where this goes. Remember, memory locations, let's call this machine example. It stands for machine language example. Memory locations are best to start at 1536 when they're in 6-page and they're not more than, I think it's 256 bytes or something like that. I think that many bytes it is, but I can calculate it. It's 1764 minus 1536, so 228. Yeah, I think it's a couple pages of memory there. But okay, so we're going to start them at memory location 1536, and we'll get back to add them in memory here. So give me a second here. I have to keep things clean. So what I'm going to do is I'm going to probably start down a few lines here. We'll start the data statements down here. You want to use a 104 to pull off the stack, otherwise usually your program will crash. Hopefully this one doesn't crash on me, but I'm going to do some calculations here. I also need to figure some stuff out here real quick. So 710 is the color of this screen here. We're just going to use 712, figure out the calculations. I think I already have it in my head, but let's see. Plus 2. I had forgotten where all the, let's see, okay, that one's pretty simple. So it's not, I think it's 200. Okay, so it'll be 200, so I'm going to store this in memory location 200, or as you see down there, 200, 2, which calculates the 712 based on high and low byte positioning, and we'll return off the stack. That's what the 96 does. So actually, I made a mistake. I don't know if you guys can see that, but I'm missing the color of the screen to change. So if you want to change this into like a dark blue or something, I think it's 52, 143 or something like that. Then we should be good on that. Okay, so you see the numbers there. Now you need to load them into memory. There's a couple ways to do this. I'm just going to read them in since it's kind of short right now. And we got 7 here. And you just read in ML or whatever value you want to poke into memory there. And you just say A, which is the memory location here. So I'm going to change this the PG6, which represents page 6. PG6, and then we're going to add the X because we're incrementing through. Actually, we're going to make this 1, otherwise it's going to increment over, so I need to make this 0, 1, 2, 3, 4. So it should be 0 to 6. There we go. Otherwise, it would start at memory location 1537, which would throw it off. So, read ML, next X. Let's go ahead and look at that, double check my work to make sure I didn't miss something up here. So we're reading in PG6, which is 1536. We're adding in each increment of X, 1536. So I think we should be good. We can check it. Just go something like this. And then you're going to peek out the memory location that you put it into. I usually like to do stuff like this. You've probably seen this trick before. Put a comma, and it'll throw commas in between the numbers. And there they are. So it's loaded in the accumulator with 143. Remember, I'll show you guys what this is doing. You see here where it says 104. First of all, a 104 is equal to a pull the accumulator. So what I'm going to do is I'm going to jump down a few lines and kind of show you the machine language for this. So 104, this is just my standard doing it. Just type a number. pull the accumulator, 220, 169, comma 143, because you're going to use 2 different numbers. I'm going to need some more room here. Let's see. Just trying to store some room here. So this one is load the accumulator with number 143. And then this one, 141, 200, comma 2. We're pretty close there, but I think we'll be okay. It's 712. And the last one is 96, or RTS. So there you go, guys. It's a real simple machine language program without an assembler here. This is what you call poking into machine language when you're just using the numbers and everything, which is why I call it ML example. I always like to put the dates into. So if you have come back into programming years, you will know what date you actually wrote it. That was pretty helpful back in the days for those people who like to keep track of dates. So right now we've got that stored in the memory. What we want to do is we're going to execute page 6. So you can use any variable, doesn't matter. And you use it at the starting address because that's where it's going to do. It's going to start reading those bytes from the very beginning and moving forward. So if I did it right, it should change the border. Or the byte crash. There it goes. It changed it white because, watch this, 143 is the white color and it just turned on the inverse. Shoot, I had to turn that thing off. Okay, so let's, can't remember how to turn the inverse off. I think it's one of these. Okay, there it goes. Okay. So poke 712, 143 is the same color. So if I say poke 712, 10, or poke 712, 50, 712, 143. You see what it did? It just stored 143 into the screen border, basically. I don't know if there's any prettier colors you guys like or not, but you can like do a purple. So you can go up here, you can change this 100, this 143 to a purple color, 100. And it'll do the same thing here once you run it. You know, it's purple. If you don't believe me, I'll reset it and show it to you. changed to purple. So it's running in the background, and it's taking that location, this number right here, I just showed you earlier, and storing it into the border. You can also do it with set color. I'm not real good with this one, but yeah. Actually, it's not even 2. I think it's 0. Let's see, 0. There's 0, 1 or something. Let's see. It's probably 1. Nope. I think it's 3. Okay. A little agitating. I need my text back here. Set color 3. Maybe it was 0. I just didn't know. I just don't know how to use it. I've never used set color, but it's supposed to change. This is 709. Okay, so this is 709, 710, 11. I think it's this one. That's it. So I think this is it right here. Pretty close. It sets a luminance. This other one is incremented, I think, by a few locations there. So see, it's kind of a red color there. So this sets a luminance kind of close to what we had, maybe not exactly. If you run the program, you'll see it changes a little bit. It's kind of a darker, so this is kind of a brighter. I think it's 16 might do it. Yeah. I never figured it out. Is it 24 increments? Maybe it's just 8. Don't ask me to explain this set colors thing. I never really tried this. I never used set color. I mostly just used the peaks and the pokes. But there's a formula behind it. Anyway, let's go back and play some more with this program. You can also change this to your regular screen. So we could change this to 710. And if you look at this 200 plus 2, like I showed you earlier, it's 256. And you drop it by 2, you get 710. So when you change this to 190, you come at 2. And this time we'll change the screen instead of the background. Play the screen again. So now we're changing the actual screen color. So those are some of the things you can do with it. Try to make this a little bit more complicated, but not too far over people's heads. But we're going to take this number right here. I'm going to show it to you. See if I can remember. 53770, I think it is. Let's see if that's it. Yeah, this is the random timer generator in the Atari computer. Notice there it's changing the numbers on the timing in the computer randomly based on an incremented clock that's changing very quickly. So that's how the random numbers work. So hopefully you can hear me. Also, you probably can't see it here, but I'm projecting everything now through a speaker I had bought. So it's bringing the sound in here. It brings a little bit better than just putting the headsets on. Plus, it's a little bit more comfortable, and it picks up a little bit more, audio that way. So anyways, let's get back to the standard here. So I'm going to basically load the accumulator with this value here, 53770, and try to see where this might be stored. I'm going to get the high and the low byte. I was doing it in a shortcut way, but you basically take 53770 divided by 208. Nope. Actually, I got that backward. Let's see. That's great. I forgot how to do the low byte now. You can take this number and you can move it and play around with it here, and you can kind of see that's it. If I set this to 255, it's at 53503, but we need 53. Is that the number? 53770. So 53770. So we need to increment this by an inner high byte. And it might be something like this. Let's say it's 100. I'm getting pretty close. 759. Oh, so it's another increment byte. You can see what I'm doing is I'm going through the high and the low bytes here through memory. There it is. It's 10, 210. So 10, 210 is the numbers we need. keep stuff somewhere. So you take 10 plus 210, as you just saw here, it has 256, and you get 53,770. So what we're going to do is we're going to change this to load absolute value. I think it's 165, but correct me if I'm wrong. I think maybe it's 173. I'm trying to do this from memory. I think it's 173. I used to have all these bytes memorized. I think it's was accumulator 173, 10, 210. So we'll do it line by line. That's this line right here. Those are the first two lines. And then we're going to store this into the 210. So we leave all that the same. Those are 200, 2, 96. And we need to increment the bytes because we added a few more on. So basically that's what we just did there, if I did it correctly. Oh, 198. So I need to change this to 198. So notice what it did is it dropped the number sign here. You saw earlier I had that number sign there like that. This absolute is just basically taking the whole number and storing it. So it's looking what you saw me do here earlier like this. It's peeking into the location like this. Whoops. If I could ever type this. You saw me do it earlier, but I just wanted to show you for purposes there. It's right there. It's just peeking into that location, and then it's going to be storing that into 710. So how many of you think you know what this is going to do? Write down in the comments before I do it and see if you're correct. Okay, so what I'm going to do is count the bytes. So we got 0, 1, 2, 3, 4, 5, 6. There's still 7. So I can, actually there's one extra. So it's 6, so it's 7. 0 to 7. Once again, always good. You just saw it, and it's working. So it's changing the colors randomly as I'm typing and rerunning the program each time. It's randomly changing the colors. Pretty cool stuff, huh? Those numbers are pretty cool to work with. I like it because it kind of picks up different numbers and everything. If you want to see what number it is, you just go like this and just kind of peek into the computer and it'll figure it out for you. So this is 112. To prove it, or 117. Right there. Now you got both screens. That's kind of a cool thing. You can actually find interesting colors. I made a color cycler one time too, where you could actually cycle through the colors. I like that green one. That's kind of cool. So, I think I might drop it down just a little bit here. So here's a trick. You can just say 710, comma peak 710, and then you would subtract it by 2 or something like that, and it'll drop the color down. Oh, that's a little bit too far. Let's make it 3. Nope. I guess that one was pretty good. Or we can increment it. Let's increment it by 2. I think that'll make it brighter, though. Yeah, that's what I figured. So I just want to subtract it, minus it. Whatever I had it as. Oh well. That's a pretty cool color. Alright, so let's see what else we can do to this little program. No way to evaluate a joystick to this. I bought some joysticks before. I might be able to do that. It wouldn't be fair to people who don't have joysticks, but I can show you. Actually, I wanted to show you this before too. I don't know why I'm getting these out. I would only be able to do that unless I had it hooked up to my actual computer, so I need like a PC joystick to be able to show you this, so we'll skip that step. So what I'm probably just going to do... Shucks. Let me just look up something in the book here real quick. I'm looking up the timing location so I can kind of change it based on color, on timing with the computer. Make it kind of run in a timing loop or something. But there is something else we could do, actually. PIC 764 controls the keyboard. So if you do something like this, you can kind of see which keys you're looking for. The space bar, and you see all these? I'm going to try to make it so when you press like a key, it changes that color according to the screen. This is a pretty simple program. It's very similar to what we just did here. You see I did this 53770. We're going to need to replace this, except we're not going to be loading into the, I think this is called the indirect addressing or whatever. We're going to be loading it into page 6, immediate value of page 6. So it'll basically be something like this. I'm sorry, something like this. So it's going to be loading into 764. So let's kind of calculate where it is. We know earlier that, what was it, 200, 2, as we saw up here, was 712. So the way to figure this one out without even looking up the high and low byte where it might be calculating it is to subtract this from this. See how many bytes come out of this. Because we know earlier, oh man, let me think here. I'm sorry, 764 minus, let me do something real quick. I'm not thinking here for a minute. So plus 200 plus 2, 712. So what we want to do is we want to get to 764. So that's right. So 764, I think I did wrong. So 52 bytes is how many we need to add to this. So 252, that should be 764. So that was pretty simple. So 252 plus 2 will now give us this. But we change this to 165. I think 165, let me see, 0 page goes up to, yeah, I think I could do that. Well, let's just try it anyway. I was trying to think if that was in 0 page addressing or is that in another page of addressing, but I think we could do it absolutely that way. So basically we're looking, and here's what we'll change this to down here. 764, so every time you hit a key, based on whatever key you run it, it should be changing this on that timing. But we also need to make a check in the loop. But let's just see what it does for right now when I run it. Oops, I forgot. Need to get rid of those other 2 lines I put in. Get rid of 1 and 2. Okay, so let's count the bytes. 0, 1, 2, 3, 4, 5, 6. It doesn't want to read in too many bytes, it's only reading in 7 here, so it needs to change this to 6. I think 0, 1, 2. Actually, it is 7. I was thinking we never added any more bytes to it, so 7. So how many can guess why it's only showing one color? Look at 764. Now notice this 255. So what it's doing is it's always leaving it at the default, which 255 is the default for 764. So we need to create a loop to change this. I'm going to write the stuff down here in the simulate language, and later I'm going to translate the bytes up here so I can kind of figure this out. So 764, so what we want to say is look in 764, compare it to see. Actually, let me see. Compare it. 764, store 764. So let's do something like this. Load the cumulative 764, so we're going to be checking register 764, and we're going to be doing it in a loop. Let's say anytime you want to know something. So what we're trying to make the program is saying when the user presses any key, the screen will reflect the new color. So basically something like that is our goal here. So load the cumulative 764. Here to see if there's a number in there. I need to look up what 764 is. Just a little research here, so let's see if we can get this goal accomplished here. Less key press. So 764 here, for guys who want to know what I'm doing, is I'm reading this location right there. See where it says, however, keep the last value pressed. Hook with 255 if no key is pressed, so that's why it was to clear it. That's why it was basically clearing every single time. I don't want it to clear every time. I want it to only clear every time you press a key. So we need to make a check for a key. Stores the value 255 here and the key code has been accepted. Actually, I know what the answer is. I just now realized how simple this was. We want to go back to this program over and over again when we're waiting for a key press. So we need to make a check. If there's no key, then it's going to say if it's equal to 255, and if you're not pressing the key, then it should go back. We could test this by doing a simple program here and just say if peak 764 equals 255 in print, or print no key, if peak, or otherwise, let's see what that does here. Okay, so that's froze the screen. So if there's no key, it's going to print no key, otherwise it's going to 1. So if it's greater or less than 255, then that means you pressed the key. So here, compare it to 255. If branch is not equal, which means that we're pressing a key, then we want to jump back up to this line so we can reevaluate 764. So I think I might be able to just do LP like that, and then store it in its rightful place. We'll try something like that and come revisit it here. Worst thing we can do is experience a crash. And compare is 201. I think B and E is 208, and it's either 208 or 240. And then we want to increment this backwards, so you have to count back the bytes 0, 1. I'm sorry, you go backwards. So 255, 254, 253, 252, 251, 250. So it's 249 because we're going backward. And if we're not going backward, then we're storing it into its rightful place. Exiting the loop. So let's just double check my work here. Pull the accumulator, load the accumulator with the 764. I'm sorry, with 252 is 764. Compare it to see if there's a 255. If branch is not equal. Oh, I think on this we also need to clear the keyboard buffer before I forget, because it's not going to be. It'll probably crash the program otherwise. When you get really good, you can just write out simple assembly language like that. And then store it in 52,2. Now we have more bytes we need to put into memory, so let me just double check this again real quick. If there's any fatal errors, it's going to cost us, so we want to make sure everything looks good. I think everything does look good here. So we count them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 bytes, so our number 40 will become 16. So we've done this successfully. Oh, I forgot. I knew I was going to do that again. Leave those irritating first 2 lines in the program. Error 6 means it didn't read enough lines, so let's see where X falls at. Why is X at 8? Oh, I only put them down here. I forgot to put the data statements in. So you can also do this. Just add them all on the same line. put down the numbers here, but I didn't put so I'll store in 710. I just refigured it out back down here, but that's basically what we're doing. So let's just double check. So 43, 255, 28, 241. Looks good to me. Okay, so let's go back and run it. Video's gonna crash on me. Hopefully we don't lose our program. So it might be 240. Nope, there's something else going on. So what you call a crash, because right now the system's trying to go through here and it's trying to figure out what the simulation program is doing. So we know right now 764 is comparing it to see if there's a 255. If it's not, it's going back to LP. So I basically, if it is 255, it should be going down here and resetting it. So we might, it should have worked on either one. I think that's what 240, I think its range is equal. I'm trying to look up the semi-language codes here real quick, guys. Sorry this is such a long video. What if I still have... I had the magazines in here somewhere because I know I made copies of the 1985 magazine, which has the machine language opcodes I'm looking for. I don't know which one of these. It's 1982, 82. Shucks. What did I do with all my PDFs? Surprised it wasn't in there. It's 1985 magazine, so it's not in there. These are all my old hard drives stored on an internal or an external hard drive, so I'm looking to see if I still have these Atari PDFs in here somewhere. But I don't know where they are right now. Might be stored away as other drives. Let's see. 2600 game manuals. Yeah. Well, so much for that. I'm going to look it up real quick here. This is one of the next best books, Machine Language for Beginners. Anytime you want to look up opcodes, it's a great book to have. So, nice about it is you can actually look these up by opcodes. I'll show you what I mean in a minute here. You see right there, where it says load the accumulator? You can actually look them up by the opcodes there. Some of these ones are in decimal. I might be wrong. No, these ones are in decimal. Like that helped me any. I can't read decimal. I'm sorry, decimal. Hexadecimal, I'm saying decimal. Hexadecimal. So, I'll look in the back. One of my puns is I never did learn hexadecimal. It's either 240 or 208. One of those is which? One or the other? So this one right here, this has all the opcodes on a certain page in the back. Right here is what I was trying to do, is get to these. So you go down here over to 208. We'll see what the mystery was. Is it down here? What's up here? Somewhere up here. Somewhere over here at the top. Now I can't even see. It's B&E is 208 and 240 is BEQ. Yep, see it right there? BEQ. Okay. So 240 is BEQ. Actually, I was right, wasn't I? Ah, good. That's what I had here. So branch is equal to 255. Means it hit 255, then we're going back to this memory location. Let's double check that too. 55, 54, 53, 52, 51. Oh! I just seen my error here. You guys probably didn't see this, but see what I was doing? Is I was actually loading this with 169, or sorry, 143, and not doing the absolute value. So in essence, what it was doing is just loading in 143 like you're seeing there and trying to compare immediate value to a number that doesn't match it. So 143 is not 255, so none of these would have ever been equal, so it trapped itself at this line. So all we need to do is change this to what we wanted, which is 764. And by golly me, I already forgot which numbers they were. Was it 252 plus 210 or something? Or 52 plus 210? I guess. 51, 24, 15, 12 it was, wasn't it? No, it was 10. Okay, so we need to compare that. Why am I saying 53,770? I'm thinking of the past number. I meant 764 minus 710. So 54 bytes. So it's basically 200 plus 54. So I think it's 254 plus 2. Shucks, I was off by number. 252. So 252 comma 2 is what we need. So this needs to be above the absolute value of 2. Excuse me. 252 comma 2, like that. We need to change the bytes too. It's all the fun in trying to figure stuff out, guys. Let's see if I can figure out the insert one a minute. Oops, wrong insert. Let's see if it's control. Nope. Maybe it's this one? Nope. Okay. I'm done trying to figure that one out. So we're just going to make some new lines here. Make sure I don't overwrite anything. I'm just putting 2 instructions per line here. Double check them to make sure they're correct. So we know that this is going to be loaded cumulative 764. This is going to be compared 255. This is branch is equal to 249. We can still change that later if we need to. And this is store 200 comma 2. Check 250. Load the immediate value of 255. Store it back into 764 and then pull off the accumulator. So I think that'll be good. We'll need to add in the extra 2 bytes. I think it was 2 or is it 1? Let's see. I think it's 1, but let's see anyway. I'm just going to count them anyway to make sure. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It was 16, wasn't it? Okay, there it changed. So what it's doing now let's do exactly what I wanted. As soon as you're waiting and you're ready to press a key, it changes according to whatever key you're pressing. That was my whole goal. The only thing is I set this for the border, so we'll change this down here to the screen. So right now, this one up here is actually the 712. We're going to change that to 710, which is 198. Now it'll change. Let me just clear this again to show you. Now it'll change the screen there based on whatever key you're pressing. If I always press the same key, like if I always press the space bar, it's always going to be red. If I always press enter, it's always going to be this white color. That's basically all it's doing, is it's going through the keyboard, figuring out what's in there, changing the value, storing it in 710, and then from here it's resetting the keyboard so that you can pick a new key again. So it works. Gets the job done, right? The video is almost an hour. I was going to try to hopefully show you another. I didn't know this one was going to take me so long to get this one done, but let's see what other kind of fancy tricks I could show you. You could also set this in a continuous loop until you press a key. Let's see if I could do that real quick here. Since we've got it waiting on a key, we'll set this one equal to 208 instead of being that. It should loop back here until it does the opposite effect. It might crash it, but we'll see. And then we're going to need it to run in a continuous loop down here somewhere. Otherwise, it's gonna kind of crash the program when we run it. I think it is. Let's see. Well, it's always going to be with a 255. So what I'm trying to do is go up here and reset it and make it go in a loop and loop back here until you press a certain key and end the program. So let's figure out which key we want to end it with. Once again, we're going to loop through the keys so we can see what key we're looking for. And as you press the keys, it shows you. So as soon as you hit space bar, which is 33, we'll make it end the program. Okay, so what we're going to do something tricky here. We're going to do a jump back to the loop. Let me see. I think that's it. Jump. Oh no, first we need to check for the key. Load the Emulator 764, and then we'll say compare it to 33. However, if it's not the right key, go back to the loop. But as soon as it is the right key, I think I just lost my 70 here or something. As soon as it is the right key, I'm getting ahead of myself here. If it's not the right key, if you hit the space bar, basically it's saying, did you press the space bar? Nope, go back here. But as soon as you do, reset the loop so that we can start over again. To start the program over again. And then just jump back to the loop again. So something like that should probably do it. Let's take out the 1 and 2 before I forget again. Alright, so let's test this out. Let's put the... oops. I forgot. I need to translate these. So branch not equal to LP. I'll translate these in a minute here, guys. Loading camera 255. Store is 764. And jump back to the loop, which is something with 76, which stands for jump back to the loop. So we'll have to calculate what that is here in a minute. I can show you right now, since we're jumping 1 byte less. Right here it starts, remember it starts at 1536 and we're jumping 1 byte forward to go back here to the loop. You just basically take the 0, I think it's +1, and it should give it, I should have it back with 1 plus 0, and then, I'm sorry, 6. It's 1 plus 6 is what it is, right there, 1537, so this is going to be 1 comma 6, so it jumps to the right place in memory. Okay, so now we need to calculate this LP, because we're going back here, so 55, 54, 53, 52, 51, 55, 54, 53, 52, 51, 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40, 39. So it should be 239 if I'm accurate on that. And this should already be 249 because 55, 54, 53, 52, 51, 50, 49 takes us back to this loop. So that's what we're doing, is we're jumping back to this loop. See what it says B, E, and E, branch is not equal. Go back to this loop, so it loops back here. And this right here is just jumping back to the loop. So it's doing the same thing, except it's incrementing to keep it inside the program each time. So it's not gonna let you run out, it's not gonna let the program end. It's gonna keep it in a continuous loop. I could have had one, let's see, this is 255. Actually, you know what? No, because this one's already gonna loop it, so we don't even need this, actually. I think I can just leave this at 96 and get away with it. So, let's see. Well, you learned a little bit extra there, but I think that would probably look right there. So let's count the bytes. We also need to poke them back in before I forget. Let's see, 173, 252, 2, 21.2. We need to change some of these up here. 255, 208, 249, 141, 252, 2, 208, 239, 255. Let's stick along the same line there. Okay. That should be good. Let's just double check them again. No room for mistakes, guys. Mistakes put you back. I think something is missing here. Let me go back and look at this. Yeah, I'm missing. No, that's right. I got 2 bytes there. I got 1 there. 208, 249. Looks good. 208, 239. Looks good to me. Okay, so let's count the bytes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, there's 23 bytes. Bytes being the numbers. That's a 23, right? Oh, maybe I miscalculated. 19. What did I do wrong here? 104, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now why do I have more down here? Oh, I think I missed this whole section there. So let me just go back up here. 173, 252, 2, 21, 255, 208, 249. I missed that section. I see what I did. 141, 198, 2, 168, 255. Now we're talking. And ooh, let me see here. Where am I at? 252, 2, I'm right there, right? So 141, 252, 2. So that's why people usually put them on separate lines. It's easier to see where you're at. And that's what assemblers do. They save you having to go through all this mess. fading. I'm not thinking very good. I think that's good. There we go. Now if I press the space bar, it was going to crash on me. So it's probably miscalculated those, I have a feeling I miscalculated this one. There it goes. So it's pressing the keys. As I'm pressing the keys, see it's changing it. And I press the space bar, it goes resets it back to 255. So that's what I wanted it to do. Kind of show it to you. See any keys I press, it's changing those colors now. So it works. I think we're going to go ahead and wrap this one up. It's kind of a long one. So hope you guys enjoyed this. Just a little Atari demonstration of what you can kind of do with your computer. And yeah, thanks for watching, guys. We'll get back to some more stuff here. Probably not as often as I used to. Obviously not as often. I have a very good social life now, so I'm not really around as much. But my car's out of commission probably for a week or so, so you might be seeing more videos like this. So thanks for watching, guys. Have a good day.